Hello and welcome to the Data Engineering Podcast, the show about modern data management. Have you ever woken up to a crisis because a number on a dashboard is broken and no one knows why, or sent out frustrating Slack messages trying to find the right dataset, or tried to understand what a column name means? Our friends at Atlan started out as a data team themselves and faced all this collaboration chaos. They started building Atlan as an internal tool for themselves. Atlan is a collaborative workspace for data-driven teams, like GitHub for engineering or Figma for design teams. By acting as a virtual hub for data assets ranging from tables and dashboards to SQL snippets and code, Atlan enables teams to create a single source of truth for all of their data assets, and collaborate across the modern data stack through deep integrations with tools like Snowflake, Slack, Looker, and more. Go to dataengineeringpodcast.com/Atlan today, that's ATLAN, and sign up for a free trial. If you're a Data Engineering Podcast listener, you get credits worth $3,000 on an annual subscription. When you're ready to build your next pipeline and want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends over at Linode. With their managed Kubernetes platform, it's now even easier to deploy and scale your workflows, or try out the latest Helm charts from tools like Pulsar, Pachyderm, and Dagster. With simple pricing, fast networking, object storage, and worldwide data centers, you've got everything you need to run a bulletproof data platform. Go to dataengineeringpodcast.com/Linode today, that's LINODE, and get a $100 credit to try out a Kubernetes cluster of your own. And don't forget to thank them for their continued support of this show. Your host is Tobias Macy, and today I'm interviewing Tristan Zajonc about Continual, a platform for automating the creation and application of operational AI on top of your data warehouse. So, Tristan, can you start by introducing yourself?
Hey, so, my name's Tristan. I'm one of the co-founders and the CEO of Continual. And, I'm happy to chat all about it and my journey to what we're doing at Continual, but very excited to be here. Thanks for having me.
And do you remember how you first got involved in data management?
I've been involved in sort of data management, data science, sort of the broad use of data for, honestly, the past 20 years. So got started in my 20s, really in the academic context, and all the way down to actually going into the field and collecting data. I was actually working with the World Bank on, research projects in Pakistan and was, actually in these villages, like trying to get data onto Palm Pilots. And then once the data came back to the central office, trying to clean it up and using sort of all the standard tools of that era, sort of the early 2000s, a lot of them proprietary tools like, SAS, SData, SPSS, then ended up in graduate school, doing a lot of research, a lot of sort of applied statistics, Bayesian statistics, increasingly sort of shifted over to the open source data science ecosystem. So that was really sort of the early part of my story when I was actually sort of getting my hands very, very, very dirty. I quickly, as part of that experience, became frustrated with sort of the state of the art for tooling in data science and felt like there was really tremendous opportunity to reimagine tooling for data scientists, machine learning engineers. Well, I guess what you would call machine learning engineers. In the past, you might call it as, statistical sort of statisticians. Then when I was doing this in sort of the 2013 era, data scientist was sort of the term that was really coming on the forefront. Sort of actually left graduate school or came out of graduate school rather than going and becoming a professor, got that entrepreneurial itch, which I'd had for a long time, and founded a company called Sense, which was really my first startup. That was really one of the early pioneering, if you want to say that, enterprise data science startups. You can think of us like, Databricks without Spark, or, Domino Data Labs is another one that was our peer at that time, really trying to build a platform for kind of code first, sort of open source centric data science teams that, are working within the enterprise and need sort of the collaboration, the security, the compute, access to data, automation, productionization aspects you'd need that you maybe don't get in just the open source ecosystem. Got into that world, sort of the startup world around data tooling. That company was founded in 2013. Ended up getting acquired by Cloudera, the big data, sort of the major provider of the Hadoop ecosystem, Hadoop-based platform. Got acquired in 2016, and then spent 3 really fun years there. That product that they acquired since became their data science workbench product. And really at Cloudera, got to see really the sort of the largest companies in the world, the largest companies, organizations, governments in the world, use data, at tremendous scale and across a tremendous, breadth of use cases, from telecom, healthcare, security, and government. That was my real education in terms of the breadth and the scale of sort of data management writ large.
And so that brings us to where you are now with the Continual product. And I'm wondering if you can just give a bit of an overview about what it is that you're building there and the problem that you're trying to solve and how you ended up settling on that as the particular area where you wanted to spend your time and energy.
I know there's so many things, to get excited about. So that last part of your question is always very apt. So at Continual, we're building an operational AI platform that integrates natively with cloud data warehouses. And so the goal is really to enable any data or analytics team or professional to build continually improving predictive models about any aspect of their business, whether it's from customer churn to inventory forecasts, without any complicated engineering, any complicated infrastructure. The secret sauce to this sort of product and not kind of the idea is really our declarative or data first approach to AI. So unlike traditional solutions, which are typically centered around, including ones that I built previously, that are typically centered around building these pipelines, centered on the model and the model architecture, centered on sort of the infrastructure management tasks you need to do to bring machine learning models to production. We basically think that increasingly AI and ML, particularly production AI and ML, should be really focused and only needs to be focused on the data, and the process can be made highly declarative. Declarative, you can think of it, like the way SQL makes analytics declarative, or the way, Terraform maybe makes cloud infrastructure management declarative, and sort of the simplification that comes of that. We think machine learning, predictive modeling, predictive analytics can be made similarly declarative, where the end user, the analytics professional or the data professional, can really just focus on, hey, what are you trying to predict, right? What is the target of your prediction? What is your definition of churn? And then that's sort of your output. And then on the other hand, what are the inputs or the predictive signals that might be predictive of that output? So, how active has the customer been, in the last 7 days? That's a feature. And really provide a workflow that is centered on those two tasks, really centered on the tasks of building up your features and your sort of feature store, if you will, that can feed into your downstream models, building up the sort of the model targets that you're doing, coupled with a tiny bit of policy, right? How often do you want these models to be refreshed? How often do you need these predictions to be updated? But that whole process can be made declarative. That's what we're trying to do at Continual. I mean, the problem, that's sort of like what we're doing without talking too much about the problem. But, the problem really we're trying to solve is the sheer complexity around operational AI or machine learning operations. And so this really comes out of my experience, over the last 20 years, but really over the last, my time at Cloudera, where I was in sort of the CTO for machine learning role, which gave me access to a lot of, like analytics and data science leaders at major companies. And what I found was, first of all, they've all actually bought into the AI ML kind of hype, if you will, or the actual transformative capabilities or potential of machine learning and AI for their business. So they all come in with, dozens of potential use cases spanning, sales, marketing, operations and logistics, product and engineering. They're all incredibly excited about that. But they all were, and this was like 2-3 years ago, everybody at that point had moved kind of away from just like, hey, we need to hire data scientists, which was maybe the 5 years ago. We need to kind of build up a basic ML, kind of capability and infrastructure. They all were saying, wow, we want to impact the business. We've got to productionize and operationalize ML. And that's, that's not a unique insight from me. The whole rise of, machine learning operations or ML ops as a kind of category is really people saying, wow, we need to get to production. We need to put models into production to have an impact. The problem that I saw at Cloudera, and I just think is really a problem, honestly, with the whole industry, if I just put a diagnosis, is that the solutions are these incredibly complicated solutions with 7 different distributed systems involved, these incredible pipeline jungles, which you're trying to bring sanity to all these different systems. Very, very code centric, very imperative based, and our belief is that's really not necessary. Like at the core, ML and predictive models are really just taking like inputs and they're a transformation to outputs, right? Like that's really all it is at the core. There's input signals, but you can think of those as features or your inputs, and there's outputs, which are your predictions or your kind of ground truth targets. And the operational aspects is often very simple. It's just like, well, how often should you refresh things? How often should these models be updated? Like, what's your promotion policy? Is it manual or is it automated? What's like the test set that you're going to make that decision based on? And that really can be done declaratively. And when you do this, you end up, basically with this sort of like radical simplification of operational ML. We think that, I think the other little bit to Continual is really our focus on the data warehouse as sort of like the center. And we just think that that's kind of the best place to sort of make this vision a reality. If you believe in sort of data first declarative approaches to AI, well, where do you plug in? And the data warehouse, is one of the ingredients that makes this vision possible.
And as far as the sort of distinction between, operationalize AI and machine learning process and making it declarative versus some of the auto ML capabilities that different companies are working for and working on, things like Data Robot is the sort of biggest name that comes to mind. I guess, how would you distinguish the use cases and capabilities of automating the model generation process in an auto ML context from automating the machine learning lifecycle process and what you're doing at Continual?
I was originally always a great, skeptic of sort of auto ML, in my earlier life. But, I do think that in terms of the model training process, in terms of finding a highly, performant predictive model, automated approaches to machine learning, using and sort of next generation, kind of similar next generation approaches, things like using pre-trained capabilities of pre-trained models and doing transfer learning. There's kind of more that you can do nowadays, sort of in that idea of kind of a highly automated or approach. That is a very exciting area. But if you look at what the core of Data Robot's product is, it's basically you upload a CSV file, train a bunch of models, and that's pretty exciting. I mean, it's amazing. You can actually do better than most data scientists can. And certainly you can get a very good performing model in a very short amount of time. Now, I think what Data Robot has realized, but what we also, they realized maybe later in the game, what we realized is, hey, that's actually not solving really any critical problem that's going to impact the business. What you really need to do is, every AI or ML use case that has a real business impact, or not every, most, the vast majority, have this continual life cycle to it, right? Data is continually flowing in, right? Even if your model is static, the data that's coming in, the signals, right? What do you know about your customers is continually being updated. Even if the model is static, like you don't necessarily need to refresh it every night. You almost certainly need to refresh it every month or every 6 months. And you probably also need to refresh it because you're getting new data sources, new potential signals. So you need to incorporate those and improve the model in that way. In order to productionize or operationalize ML, which is required to have a business impact, you really need to think about the sort of the end-to-end life cycle and automating the end-to-end life cycle. And then, it's not really automated ML. That's where we think of it's really more of like declarative AI or declarative operational AI. It's really, yes, there's maybe potential for auto ML at that little core little bit where you train the model, and there's potential to leverage auto ML and similar technologies there. But really, it's about the workflow around the entire life cycle, from training to inference to monitoring to iteration, right? Development to production. So how do you experiment with a new model or experiment with a new feature and see the impacts of it, then put it into production, then automate the life cycle of it. And if you build with that workflow and kind of end goal in mind, you just end up with a much different product. You can simplify, the whole experience. Versus, I think if you just start with a kind of the core AutoML and you're like, well, let's put these deployment, let's put a little container deployment platform on there, and let's put a data processing platform. It doesn't allow you to kind of think from first principles and realize, wait, this whole thing can be made essentially a data management task, where you're managing features and you're managing targets and your ground truth and your predictions, and then a little bit of declarative kind of policy around, how to orchestrate things, like how often things should be refreshed. And you end up with a sort of a very different product that results.
In terms of the definition of operational AI, you've mentioned that a couple of times, and there are a couple of different ways that it seems like it could be taken, where it's the operational aspects of putting machine learning into production, or it could be application of AI to operational concerns of the business. And I'm wondering if you can just discuss sort of how you think about operational AI in the context of the technology and the business, and some of the ways that that might differ from some of the other ways that machine learning or AI might be used in a data science team or in more of sort of like a research or exploratory context.
Yes, I mean, the term definitely can be interpreted in those two different ways, for better or worse. When I think about operational AI, I am in many ways thinking about it in that holistic, in both of those ways, right? In my view, operational AI has to be in production, right? So it definitely is not, research and development. It has to be driving some business impact, right? So it has to actually be useful to some business process, whether you're automating a business process, building a better experience, streamlining some operational aspect of your business. And then, finally, my view is that it's got a continual life cycle. I think that last bit, I would say, is the real overlooked differentiator. There's a lot of, for instance, if you look at the machine learning operations platforms or solutions out there, or sort of the excitement around machine learning operations. And this is changing a little bit recently, but traditionally they were very focused on, for instance, building like model deployment tools, right? Here's a way to host a model and serve a model as a REST endpoint or something like that. And that was sort of Gen 1. Gen 2 maybe is, let's put some better monitoring on it, right? Let's have better monitoring explainability. And that's, machine learning operations. Okay, machine learning operations is we deploy a model in a container and we monitor it, right? That's machine learning operations. And I think what more and more people are realizing now is that really pretty much every model that's kind of operational and in production has a continual life cycle. And you really got to think about that continual life cycle. If you don't, you're missing, in some ways, some of the hardest and most challenging and most impactful aspects of that. If you don't deal with it, you're going to impose tremendous costs on your team, both from an infrastructure and from just a time perspective. That's how I think of operational ML. The aspect of like, well, is it on, targeting your product and engineering, personalization within your product, or is it targeting like, your finance and marketing and sales? I think operational ML can be either. We at Continual, are focused on use cases that are best driven off of your data warehouse, which are very commonly are use cases that have this sort of business operations aspect to it. And so there's a nice little double meaning there for us in terms of what operational ML means.
And then as far as the sort of challenges and barriers that organizations run into as they're trying to adopt predictive analytics and AI capabilities in their business, what are some of the issues that they typically run into and some of the ways that the sort of declarative approach that you're building with Continual is able to overcome those barriers and challenges for them?
The first problem that we see when we talk to customers, is data. So is honestly just like, do you have the data to actually leverage ML? And for some customers, that is clearly the case that they have the data, right? If you're a large retailer, you have a tremendous amount of data on, for instance, your sales, your inventory levels, at a product level, at a store level. And you unquestionably need to leverage, machine learning to do forecasting, right? You're probably in a low margin business. A lot of it's the sort of the margin from your business comes from your operational efficiency and making sure you don't waste, huge amounts of food, or you don't run out of, critical items where you lose revenue opportunities. That's something that you obviously need to solve. There are other, types of companies. We deal with a lot of customers who are interested in, understanding and applications of ML to understanding their customers. And, you need a certain amount of customer interactions to be able to do that, right? So if you're a startup and you're in the B2B space, you're selling to other businesses, often maybe you have a couple hundred leads or a couple hundred customers, right? You might not be able to fit a great churn model with a couple hundred customers. On the other hand, if you're, doing a B2C case, where you have thousands, tens of thousands, hundreds of thousands, millions of customers, right? So the first one really, I think in terms of challenges to leveraging ML, first one is you got to have the data. Both the feature data, that's the signals that are predictive of whatever you're trying to predict, and then the ground truth. You need some sort of ground truth in terms of like, what are you actually historical evidence of what are you trying to predict? Conditional on you having that, kind of that's just what you absolutely need. You then run into, I would say 3 main challenges. The first is infrastructure. Do you have the actual infrastructure to do ML? Well, traditionally, right, that's like, do you have Kubernetes and containers and like notebook infrastructure and ways to run Python and maybe get access to GPUs if you need GPUs and get access to your data securely and, how to automate that whole process and, write it back, and monitor and all that stuff, right, for the infrastructure behind ML. Some of it, which you may have from your data infrastructure, but some of it might be unique. The second thing you need is you need people. And certainly if you're going down the traditional path to ML, that's a big challenge because, you often need, kind of cloud engineers, infrastructure engineers to kind of get you going. You need data engineers to really get your data in the right place and kind of set up the right data pipelines. And then you need, data scientists or machine learning engineers people who actually understand the science, understand, well, how do you do forecasting, right? When you have, covariates and when you have irregular time intervals and you have missing data and you have all of these real world challenges, those, people, have that sort of scientific understanding. And you need to form a whole team that works well together. So there's this kind of people challenge. And then the final one, which I actually hear, a tremendous amount, is just time and ROI, right? It's just like, if you can pull this off, you might be able to, get the infrastructure in place, recruit the team with all of these characteristics. But if you've done that, you better hope the ROI, to your use cases and the cost of maintaining it is high enough. And, typically, with the business stakeholders or within a company, when you talk to them, they actually have like dozens of use cases. A lot of times the ROI of any particular use case is a little bit uncertain. You kind of want to take this portfolio approach where you try a whole bunch of things. Some pay off and some don't work because you maybe can't predict as well as you want. But the problem is if it takes you a ton of time, right, to implement every use case, let alone maintain it, and so you can see the kind of the impact over a year or something, you end up just not having the time to do all the use cases and see the impact that will then justify the people and justify the infrastructure. I kind of like, those are like four problems, right? You have data, infrastructure, people, and time. The last three are like really the ones that Continual is focused on. We want to sort of eliminate your need for infrastructure, do that by being kind of a fully managed kind of cloud product, kind of connects directly to your existing data infrastructure, namely your data warehouse, which is where effectively everybody is currently or will be storing the vast majority of their data, bringing together their data. Then we try to radically broaden the number of people that can do machine learning to sort of solve the people problem by enabling any data or analytics professional to be able to do predictive analytics as easily as they can do kind of historical analytics. Kind of finally just radically accelerate or reduce the sort of the time to initially building a use case, right? So dramatically drive that down. Dramatically drive down the time to iterate on a use case. So if you have a use case and you want to improve it, because there is always an aspect of, hey, there's more signals that we can have here, or I'm slightly changing my definition of what I'm trying to predict. So the time to iterate. And then, I think what people often forget is the time to maintain or the cost of maintenance. And so really just allow it to be essentially free once you've kind of implemented it, which hopefully doesn't take too long, essentially free to maintain. Whereas I think traditional solutions, sometimes it's okay to maintain, like you'll do an okay job maintaining it when you have your whole team there who like set the whole thing up. But, typically with these highly bespoke approaches, at least what I've seen is that it's a very exciting kind of work for a data scientist to do, a machine learning engineer to set that up and set these use cases up. But then they leave the company, in 2-3 years, somebody else comes in and, almost always, it ends up being perceived at least as sort of like this incredible tech debt, right? Of kind of like these bespoke pipeline jungles, like technology that was, of particular era or that this particular engineer was familiar with and this other engineer is not. And so you end up with this like very difficult, kind of to maintain, systems, which becomes very costly. Like I even talked to customers who are like, decommissioning use cases because they're just, too costly to maintain it if you do it in that way.
And as far as the target users for the Continual product, who are the sort of members of the business that are going to be interacting with the platform and defining the model definitions and writing the sort of declarations of what they're trying to get out of it, and sort of who are the various stakeholders that you anticipate interacting with the platform as a whole, and some of the ways that has driven the sort of product focus and feature priorities?
Yeah, so we think of our target user as really any data professional. So you could think of that as a data engineer or an analytics engineer. You could also think about it as a data scientist or kind of a pragmatic data scientist. We're not as great a fit for like the machine learning engineer who's like really pushing the absolute frontier of, the architecture of some TensorFlow model. Like we're not trying to build like an R&D platform where they're like managing like some of these experiment platforms like weights and biases. Like, we think those tools are great. So we're really trying to say, you're a mainstream business. Like think, I like just walking around the world and like looking at companies and like being like, okay, here's Gap, right? Like how should Gap do their machine learning? Or like, there's the FedEx truck. Like how should FedEx do it? Or, a plane is in the sky. Like that's JetBlue. Like how should JetBlue do all their, their arrival time forecasts, their like fuel forecasts, like their customer support, call center, like how many people they should staff their call center, right? If I think about all those use cases and then I hang out with my sort of ML engineering friends, I'm like, often the answer is like, well, they should set up, Kubeflow and MLflow and like containers. Like, I don't know. That doesn't seem like the right solution. So for these like mainstream, it doesn't seem to be the right solution if you want to make AI and ML pervasive. And so I think if you want to make AI and ML pervasive, you've got to democratize AI, at least to any data professional, right? Anybody who's was working with Snowflake or working with Redshift or BigQuery or Databricks Delta or something like that. They should be empowered to very, very quickly kind of build professional model, to build these predictive models. I think the end user persona that we're going after is really just like anybody who like knows data, understands their company's data, understands how data might or predictions might be able to impact the business. And that's kind of like these data and analytics teams or kind of pragmatic data science teams. Of course, there's a business stakeholder who's often driving the use case. There's a demand from the business. They're more kind of saying, hey, here's what I want, right? There's still an end user needs to do it. I guess to go a little bit further on this question, maybe further than you asked, is Another way, I sort of think about this is like the different kind of tools that are out there. I think there's, one set of tools which is quite mature, and this was my previous life where it is targeting the sort of the machine learning engineer, right? These are like these Kubernetes-based machine learning platforms. They're great, right? Like that's like AWS SageMaker, giving you all the building blocks. If you're a machine learning engineer, you can put them all together and you get a lot of control. And that's kind of like these Gen 1 sort of ML platforms. They're increasingly adding like operational capabilities, which is good, but they're still like very low level, kind of very code centric, don't have a high level of abstraction, but a lot of control. I think there's another class of tools out there, which is that people recognize, hey, we need to obviously democratize AI. And they kind of go, oh, let's build no code AI, right? And, no code AI where like this business user is going to come in and click around in something and somehow they're going to have like some tremendous business impact as a result. I think there's some opportunities for that, but what I've seen within the data sphere is you do want to democratize things, but if you're dealing with operational AI or data or analytics, right, somebody needs to be on the hook for that, right, and that takes it really seriously, right. So if you want to do, I think, even business intelligence seriously, like some of the tremendous success of a tool like dbt, data build tool, on one hand it's democratized, it puts SQL at the center. But on the other hand, it actually embraces some of the best practices and brings some of the best practices of the engineering culture to the SQL persona, or the analytics. They're introducing kind of this term analytics engineer. What I mean by that is like, the ability to like do version control of your models, the ability to do, development, sort of like experimentation, and then, open a pull request and actually merge it in, right? To have governance over the way your models change. And so I think declarative AI actually has the power, not just continual, but like if this becomes a kind of a trend and a category of tools and a workflow and experiences, is going to kind of be this similar middle ground where it says, look, we do believe we can dramatically democratize and simplify ML, including the operational aspects of it, but we are going to still maintain some engineering best practices, things like the ability to, if you want, version control things. That means like, there should be a configuration driven approach, whether it's, you have a UI, you can do that in the UI, but you should also have some way to follow more engineering best practices. Because if you're doing a really, really mission critical use case, right, if you're JetBlue and you're forecasting your arrival times and your fuel forecast, you better have governance over that whole process, right? It still can hopefully be easy, right? It can be like managing your cloud infrastructure with Terraform or something like that, where you don't have to have all these scripts, bringing up and maintaining and monitoring, all of your cloud instances. You can have a high level abstraction, but you still should have some sort of middle ground. That is definitely, I think, one of the unique aspects of what we're doing at Continual, sort of in the AI sphere. But I really think that that's going to spread. I mean, I think that's inevitable that people are going to see the value of that and that kind of idea of, simplicity, but, still robustness. I hope it spreads. I hope it spreads.
I definitely agree that sort of the declarative aspect is a necessary next step, and that we're reaching that level of maturity in the industry where more people are recognizing the capabilities of machine learning and the potential for it to be transformative for their business. But it has been a barrier to actually put in all of the engineering groundwork to get to the point where you get it into production and can maintain it. But, being able to just say, here's what I want, here's the data, now I don't have to worry about what's actually happening under the covers. It's just going to do what I want it to do, is going to be a sort of massive step forward for businesses in general. And so in terms of how that's actually sort of manifested, I'm wondering if you can talk through some of the ways that the Continual platform is architected and implemented, and some of the sort of interesting engineering challenges that have come about as you've gone through that process.
So, the first part is really, what is the declarative abstraction, right? And I think, that is a challenge, figuring that out. So, right, SQL did that with analytics, but there was competitors to SQL, back in the day. Now SQL has become the sort of the lingua franca of analytics. But there's a kind of a question, okay, well, I like the idea, I understand that ML and prediction is kind of like inputs and outputs, and, it can be data first, but like, okay, you can have some policies around retraining, but like, what does that abstraction layer look like, right? Does it look like SQL? Does it look like Terraform? Does it look like something else? So I think the first part of Continual is really trying to define that, that declarative abstraction. The way we've done that, we've bet on the fact that data within most enterprises is relational and temporal. So, you have business entities like your customers, your leads, your products, your sales at a particular store, that's typically kind of has this tabular kind of structure to it. it almost always has a temporal nature to it as well, or many use cases do. And the temporality of data is critical for ML use cases. You have to take that and make that a first-class concept if you don't want to have data leakage problems, right? If you're trying to predict churn, and you're saying, okay, well, is this person going to churn at the end of their contract? You need to be able to go, or, in the next 30 days, you need to have historical data where you can kind of go back in time, have this sort of time machine characteristic where you have a feature like how active they were on the platform, on your tool, your website, or how much did they buy, which would be a kind of predictive signal of churning. You need to manage that in a way that, you respect the time dimension to this. So you use that to then predict into the future. So the first is kind of like getting that abstraction layer right. We have this sort of like, sort of temporal relational model that is very well suited to layer on top of a data warehouse. So the second thing is, what do you connect to? And, I think, and this was actually a lesson that we had at Continual, was if you try to do, too broad, right? If you say, well, you should be able to connect to Kafka topic, then do streaming processes on Kafka topic, then you should be able to have APIs that you can hit and get real-time features from APIs, right? These are like, if you look at the feature store, literature or ML platforms, there's a lot of connectors, right? You should be able to pull data out of Salesforce yourself, or whatever it is. You would kind of end up in this like mess. Actually, just things that we kind of lucked out on, I think, that kind of coincided with the creation of Continual, or like wanting to build a company like Continual, was the rise of the modern data stack. And by that, I mean the rise of like the data warehouse, the cloud data warehouse, Snowflake, Redshift, BigQuery, Azure Synapse, Databricks, Delta Lake, and many more, but those are the leading ones. The rise of that architecture that puts sort of like the data warehouse at the center, you bring all your data in there from all your different touch points. That's where you can process it, merge it, clean it, et cetera. That actually provides this like really nice kind of connective place that Continual can connect to. And it can help inform the abstraction that we build on top of it, right? So it can say, when we talk about features, we can talk about features with respect to, well, in registering features, those features can be defined, using SQL. When we define your targets, like what is churn, we can define that, using the language of SQL. And then it becomes a data management layer that sits on top of, sort of a semantic layer for ML that sits on top of your data warehouse. And then from that then drives the continual, model maintenance, prediction maintenance issue. What does that look like? How does that implemented? Continual really has these three layers. We have the data plane, which is the data plane is really responsible for translating our declarative configuration, into the actions that need to be taken to refresh models, to refresh predictions, to profile data, monitor data, all the things that you would kind of typically do if you're like really serious about operational ML. We have a control plane, which is, you can think about it as the metadata layer, the collaboration and metadata layer. So this is where all that kind of metadata is being stored around the performance of models, the profiles of your data, so you can do data drift and things like that. The collaborative aspects, like collaborating in isolation around your projects and bringing people on and visibility, all that sort of stuff. And then of course, we're a cloud application, so we have the front end, and we built the front end, which is one, it's a kind of a standard SaaS application, but you also have this kind of total parity with your kind of a CLI. So if you're more of an advanced user, if you want to drive things off of a CLI kind of version control, even pull requests, you can do that. If you want to be in the UI, either to monitor from a read-only perspective or actually to do some authoring, you can do that as well. So there's kind of these three layers to actually like how we translate that declarative vision into reality.
And you mentioned that when you were first iterating on the problem, you were sort of considering being able to hook into things like Kafka for being able to feed off of streaming data as it's going through those systems, and then deciding that the data warehouse was the sort of natural fit for the product that you were building. I'm wondering, what were some of the other sort of lessons that you learned in the process, or assumptions that you had at the outset that were challenged or updated as you dug deeper into the problem and started working with customers about sort of the ways that they were thinking about how to interact with the platform that you were building?
Unquestionably, putting the data warehouse at the center is probably the biggest and most important strategic thing that we've done, and has been a little bit of an evolution, from the first 6 to 12 months of Continual. We always knew we want to sort of combine the ideas of like a data-centric ML, which was with the idea of a feature store, with the idea of automation, sort of continual automation of predictive models, declarative AI. We were very inspired by some of the research around declarative approaches to AI. Things like there's open source projects like Ludwig, open source like papers that have come out of the research world, like Overton, which is a declarative AI platform that Apple has talked about publicly. So we thought, well, there's tremendous power there. It's actually amazing how much you can do with this declarative AI. Okay, well, let's couple it with the idea of data being central for really operational AI, we can build something unique there, a sort of unique take on the ML infrastructure. But I think the big question when we talk to customers, when we would kind of demo even the early versions of the platform, which was how do I exactly fit in? We realized our whole goal is simplicity here, and the data warehouse, by putting the data warehouse at the core, all these simplifying assumptions just start to unlock for us and for the customer. Because all of a sudden it's like, hey, I know how to get data into the platform. I already have that. I have Fivetran that's going and pulling data into my data warehouse. It's like, I know how to get my data out of the platform. I have my BI tool, that's already hooked up, my Mode or my MicroStrategy or Tableau or Looker or whatever it is. And now increasingly like, hey, and a recent trend that we're seeing, which is incredibly exciting, is like the reverse ETL movement, which is, like the high touches and the censuses of the world, which are allowing you to pull data out of your data warehouse and put it back into your applications where it can be used, right, and impact the business. And the beautiful thing for us is, hey, we write predictions back into the data warehouse. So if you want to have a churn forecast, yes, it should definitely show up in Salesforce. It should show up in HubSpot. It should show up in Braze, which is a marketing kind of automation tool if you want to send like custom personalized emails. So all of a sudden the whole stack, starts to play together. Like the whole ecosystem plays together. Really, I would say like the biggest thing that we've done, that lesson that we've learned is like, there's tremendous benefits to putting the data warehouse at the center in terms of simplification. And that's the biggest one. Slightly smaller ones are, what is the right data model for feature management, data management? What is the right sort of like semantic? This is kind of like, what is this declarative, interface? And, it's not, I wouldn't say it's one change we've made, but we've continued to try to balance like, simplicity versus flexibility. We have big debates on like Snowflake schemas versus star schemas versus Galaxy schemas. And, like what's the right mental model for things like that. And we've continued to refine some of those, the sort of the exact way we express a declarative sort of setup for machine learning.
Schema changes, missing data, and volume anomalies caused by your data sources can happen without any advanced notice if you lack visibility into your data in motion. That leaves data ops reactive to data quality issues and can make your consumers lose confidence in your data. By connecting to your pipeline orchestrator like Apache Airflow and centralizing your end-to-end metadata, DataBand lets you identify data quality issues and their root causes from a single dashboard. With DataBand, you'll know whether the data moving from your sources to your warehouse will be available, accurate, and usable when it arrives. Go to dataengineeringpodcast.com/databand today to sign up for a free 30-day trial and take control of your data quality. For somebody who is using Continual, they've got their data in a data warehouse, they want to onboard onto your platform and start being able to take advantage of the predictive analytics and the predictive capabilities of understanding, what are some of the forecasts based on the data that we have. What is the actual workflow for being able to actually get set up and start to build a model and put it into production and see the predictions and outcomes of that and any sort of data modeling considerations that go into the onboarding process?
So there's really, three steps. So, step one is you connect to your data warehouse, right? So that is like any other, like how you would connect your BI tool or how you would connect Fivetran or ETL tool. So, give us some scope down credentials that allow us to get access to, data and basically, rights to a schema inside your data warehouse where we can then manage the features, your feature definitions, which we call feature sets. These are like the features on your customers, for instance, and manage the predictions. So both your historical predictions, kind of an audit log of predictions, and also your kind of the latest predictions. And so we kind of take over a schema inside your data warehouse and continually maintain that. So one is just connect to that. That's just a connection. That takes, 3 minutes, right? The next step is, setting up these problems. And in our system, there's really two tasks that you can do. One, you can focus on what are the features or the inputs that are going to go into your models, right? We call those features or feature sets. A feature set in our world is like a collection of features on an entity like a customer or a product, right? That feature, has a primary key, right? Like an ID, like customer ID, and it also has a timestamp. Like, so what time did that feature exist at? So that's like kind of gets to what we need to do, like this time machine capability with that feature stores have. Virtual feature store, right? So we're just a semantic layer on top of your data warehouse. So one thing is you can do is you can organize your feature data. You can then use all of those across all of your different models. Like as you build your models, you don't really need to think about features. You can just, pull in all the features from your feature store automatically. The second thing you can do is you can build a predictive model. But that predictive model process starts with, okay, what is the model data set? Namely, what is that spine of the model, which is, essentially, again, like what is the entity that it's on, like your customer? What is the timestamp? Like when are you trying to make the prediction as of? And what is the ground truth label? Like what is your definition of churn? You might have, some historical data on churn for your customers, and you probably have a whole bunch of data that you don't have, so you want to predict it on. You just need to set that up. If you're using DBT, it might just honestly be a table that you just register with us, and you just say, hey, this is my feature table for customer features. This is my model for this is my churn table, or I have churn over time for my customers, and we then can join it together. We join it together in a way that's like point in time correct. That's kind of like the term of art, which just mean like you get the features for every point in time as necessary, and so we generate all those queries kind of for you automatically. You set that process up, that's again, like, if you understand the system, like once you've done it, it's like, 3, 4, 5 minute process to like, just say, hey, like, here's a new target, like not churn in 30 days, but churn in a quarter, 90 days, or churn after the contract expires, right? Multiple definitions that you might want to use. You just need to define that, register that with our system, submit it in, then last step is a little bit of policy. By policy, I mean, how often do you want the model refreshed? What exactly are you optimizing for if you're a more advanced user? Like, do you care about accuracy or precision or recall or AUC or something like that? That's where the data scientist, says, oh, I want to do that. But the other person says, just tell me something to do that's reasonable. Then how often should you refresh the predictions? And then you submit that into the system, or you kind of push it into our system. At that point, the system is on autopilot. We just, do a first run where we train the model, we profile the data, we run the batch prediction, or we run a prediction job that puts that data back, those predictions back in your data warehouse. And then we maintain that, maintaining the model, refreshing the model, maintaining the predictions. So the whole, life cycle, that whole thing becomes kind of this living process, and then maintain a lot of visibility into all of that. So, the profiles of during training, what was the distribution of your predictions? During inference, what are the predictions of your distributions? Are they drifting? What are features are important? What are the marginal dependence plots? I mean, you can get all of this. I mean, the beautiful thing about sort of like having abstraction is you can build all of this stuff for free on top. So, it would typically take a data scientist, weeks. You kind of just get it for free. And so the end result really is, if your data is in reasonable shape, you can, put a model into production, I mean, really in minutes. And what's amazing is that literally it's actually in production. I mean, I think even internally, sometimes we get shocked, where that's actually in production for this customer. We just did a proof of concept with somebody, and, they gave us access to data, and we were like, hey, let's do a one use case. And Jordan, who's on our team, who leads our field engineering team, he literally implemented, a production model for them in like, an hour and a half or something. And was like, hey, check this out. Let's jump on a call and let me onboard you. And so you can do this yourself. Coming from my background where, I was writing Python scripts and Python pipelines, and, even to just POC it, like in a notebook took me a week. Then let alone figuring out how to deploy it, that experience of where you can put a model into production, in minutes is like pretty cool. Like it's a nice feeling.
In terms of the sort of model lifecycle aspects, obviously you're managing the retraining and understanding when there's model drift happening, but for teams that want to have more visibility into what the model is doing or wants to be able to sort of dig into some of the explainability aspects of the model, what are some of the options that they have for being able to interact with the model as it's running to get useful metrics out of it, or be able to poke at it to understand sort of the reasoning that it's using for generating a given prediction for cases where they need to be able to have that auditability for GDPR or CCPA or other sort of regulatory regimes?
Yeah, I mean, that's a huge topic because there's so many different aspects to this, right? There's everything from, of course, you want to know the performance of the model over time, at the training time performance, with your test set. Then you might want to know your performance with the true out of sample test set that maybe comes in later, because you get some ground truth for many of these applications, your churn, right? That comes in actually way after, which is in some ways often the truest signal of your performance. You want to know things directly with respect to the model, what features are important, what features had the biggest impact, which direction was the impact, is it nonlinear, is it linear impact, are there influential or outlier data points that are driving your results, right? For an individual prediction, what are the individual features that drove those predictions, et cetera. We do a lot today. We can do a lot more. We were always, adding things and trying to get customer feedback on this. So there's a lot to do here. I think what's amazing is that these are really I think people often think, wow, it's really bespoke to my model. But what we've found is that's really not true. I mean, the vast majority of these things, if you have regression or classification, the vast majority of things that you want to do are things that you can sort of automate away, right? And like you might need to ask a little bit of information, right? So like local feature importance, kind of per prediction feature importance is a time consuming task. So it's like, do you care about that? Because you might not want to do it if you don't care about it, right? So you might say, okay, well, that has to be a configuration thing that somebody could set. Or, another one that has come up is, sometimes you want performance by a particular subsample of your population. So you want to do slicing. So you don't just want performance of your model, but you want performance within, by state or by, gender or something that you might care about or something like that. But, I think the nice thing about sort of a declarative approach is it actually gives you a structured way to think about those things and say, hey, what are the things we want to do? Okay, we want slice-based performance. Okay, that's what we want. We want feature importance. Okay, and feature understanding. What is driving the prediction? Okay, what are the set of diagnostics that we can do for that? So yes, I think that's one of the reasons why, if you're just thinking like, people put ML in SQL, it's not really enough, right? You really do need to think about all of those other things. So we're doing a tremendous amount of that stuff. We're always adding more, right? We're still an relatively early stage startup. We're certainly adding more. I think the second part of your question, which is also something that we're working on, is, how do you do, higher level of abstractions are fantastic, but it's often a hierarchy of abstractions. So how do you have revealed complexity where you keep the top very, very simple, right? The data scientist who comes in, has the control or has the ability to get deeper in. And so, we're also, trying to figure out what is the right extensibility, the hooks where somebody does want to be able to get in a little further, either to understand things or to kind of tweak things. And that's, I think, another, challenge. That's with any kind of high level abstraction, right? SQL, should you have UDFs or, that's kind of like a similar thing that we might experience. Like, should we have custom loss functions, for instance? That just came up in a conversation yesterday with a customer. So how should we best expose that to them? That's going to be a little bit of an evolution. I think once you kind of implement something and you see, wow, how fast it is, and then how much visibility you do get, for a lot of use cases, you're like, this is good enough, right? This is good enough. And then I think for those 5% of use cases, hopefully we have the hooks to do, and platforms like Continual that have this declarative nature have the right hooks that you can get in deeper, or there's no shame in, pulling out one model and putting it into your Airflow DAG and, doing it over there. You can pull out your features. All of our feature data, all of our tables are sitting there in your data warehouse. You can access it. It's not locked in. There's no lock in there. It's going to take you 20 times as long, unquestionably, but it will give you every bit of control you need.
And then in terms of the sort of declarative model that you're building for people to be able to interact with Continual, I'm wondering if you can talk through some of the sort of design and development process of what you went through to figure out what are the useful abstractions, what are the knobs that people need to be able to tune, and sort of the syntax for being able to write this declaratively in a way that is accessible for somebody who isn't a expert research data scientist, but has the sort of general domain and data knowledge required without necessarily having to be a full programming language, into some of the sort of balance that you decided to strike there and some of the considerations that you built into the way that you're presenting these abstractions.
Yes. So number one, unquestionably, is the fact that we embrace SQL and use SQL as the data warehouse, as the way you manipulate data. So if you wanted to define a feature, as you organize your data, the way you do SQL, that is the primary escape hatch, right? It's a tool that's familiar to essentially every data professional. It still is a challenge, right? As you do these aggregations, right, to create features, there's still work to be done there. And we're doing some things around, automating even some of that. Is there potentially an abstraction layer that is one layer above SQL for some very, very common things? For instance, like roll-up queries, which are very common in feature engineering. So there's some things we are planning to do around that. But basically, the fact that the choice that we did not have to invent another language, right? We're saying, you're just writing SQL. It's not R SQL, it's Snowflake SQL or whatever SQL of your underlying, or you're using DBT, right, data build tool already. And so it's just extending that and kind of providing a little bit more structure on your DBT models and then registering them with our system. That's the hardest bit in terms of that's the stuff that you could, I think, go down a crazy wrong rabbit hole if you tried to do your own, YAML-based, feature engineering, something or other, right? So that's one big design choice. The other ones, as I mentioned earlier, we have these kind of core abstractions around, you have entities and, which is your customers, and you have feature sets, and which are a collection of features, feature tables. You could think of it for feature views. These things have, primary keys and they have timestamps. Honestly, there's a lot of convergence happening within the feature store space, not total convergence, but there is sort of a lot of convergence around this kind of mental model for, organizing features. The remaining challenge, I think, and that I think it's all pretty straightforward once you interact with one of these systems and kind of read the docs once. You get the picture. We're trying to stay very close to the way, people understand data warehouses and data in general. So we're not trying to invent too many new terms. The remaining challenge, I think, with respect to ML is really around framing the problem. When you're talking to analytics and data professionals who maybe aren't living and breathing ML, there is still the need for somebody to just sort of translate the business task that they're trying to do, like churn, into how should you think about that, right? So, for instance, with churn, which is, literally like the canonical example that people talk about when they think about like, pretty basic ML, a lot of times people have like, a flat data set. You have a bunch of customers and you have churn as a column, right? That's like the Kaggle version of churn. But, that's really not how like the real world operates. Where's time in that, right? Everybody's going to churn at some point. They're going to die and they're going to churn, right? So you really need to frame it as, when are you going to churn? And then you have to make some decisions, right? Are you saying like, am I going to churn within the next 30 days? That would make sense. That's a good idea. You should take your features, your signals, what you know about the customer at the beginning of 30 days, look at over the next 30 days, did they churn? That's kind of your historical data, then train a model on that, then do a forecast going forward based on that. But the data scientist will rightfully bring up the point that you have customers with different, duration contracts. You have, 1-year contracts and 3-year contracts, and you have month-to-month contracts. And, then you have to make a decision, which is a little bit of a business decision. Do you want to model that as you will still do monthly churn? And of course, a feature that says you have a yearly contract or your contract is expiring in, X months. Well, it's going to expire next month. Well, that's obviously going to be highly, highly, highly predictive of churn, because it's going to guarantee you don't churn if, you're not in your last month. But you need to set that up. Or do you want to, predict like, what is the probability of you churning at the end of your contract duration? And so that's the prediction problem that you want to set up. Our view is that we believe that data scientists and people that understand ML are critically important and like absolutely are, we're not trying to replace them, but we just think that they should be focused on kind of two things. They should be focused on the business problem, like what are you trying to do? How are you trying to have an impact? What does the business need? Answering questions like this, right? Like what does the business need in order to be effective and to have the biggest impact? And then secondarily, okay, what is the data? How do I define that, churn outcome? And then also, and this is really what drives, honestly, predictive performance. What are the signals, right? What are the things? I mean, and they're very bespoke. Like we were just talking to somebody who, I won't say exactly the use case, but I mean, these predictions of churn, for instance, you need to understand your business and say, hey, if they're this active on the platform, or if they take these specific actions, that's very highly predictive. If they, invite a peer onto the platform, and send an invite, maybe that's highly predictive of churn if you're kind of more of a product-led growth company. And, data scientists, in our view, really should be focused on those tasks, kind of those two tasks: defining the problem, setting up the problem, conceptualizing the problem, and then kind of the data. The rest, not so important. Like even loss functions, right? Typically not so important.
And then as far as the sort of usage of the Continual platform and this overall declarative aspect of AI, you were mentioning that you're sticking close to SQL as the interface for being able to interact with the platform and be able to describe the models. And I'm wondering if you can just take a brief minute to do some compare and contrast between what you're building at Continual and some of the work that's happening in database engines to try and push machine learning into the engine itself, thinking in terms of things like what's being offered by Vertica or BigQuery, where you have a function defined in the database engine that you can call to create some prediction based on some set of columns.
We love SQL at Continual. I actually am not really a big fan of putting like the train and predict function inside of SQL. I'm not a fan, or am a fan. I just don't think it's really solving a problem that's very important. So it's kind of, in my view, like that, train and predict inside of SQL, like as a UDF or whatever it is. It's like an alternative interface to scikit-learn fit. Scikit-learn is like what you would do in Python, the vanilla, regression or classification, interface. It's a one-liner, right? It's fit and, to fit a model and to predict to predict your predictions. And the sort of BigQuery ML and the equivalents are essentially different syntaxes on that. And it's okay. You don't have to move the data quite, so you don't have to read the data in, don't have to write the data back. So there's a little bit of, nicety that you get there. What we think at Continual is that like every real world use case is much, much more involved in that, namely because of the sort of continual operational life cycle that you need to manage, right? You need to think about all your features. You need to manage your features, collaborate around your features. You need to, manage your models and have the features feed into those models. You need to retrain your models. You need to look at the performance of those models over time. You need to deeply understand those models. You need to have data drift and prediction drift, and you need to have performance, after fact performance and, test validation, performance and feature importance. And, it really becomes this much large, like the challenge, the problem that you're trying to solve is not like, hey, here's like a different, calling syntax for train and predict. It's really like, what is the workflow to operationalize ML? And I think the kind of the in database ML people, aren't really taking that. They're like, oh, it's really cool that we can actually, put a train and predict function inside the data warehouse, which is cool, but it doesn't really solve the problem, right? Like if you think about you're a major retailer, right? You're doing forecasting use cases. I think to me, I would really think of it like, hey, I really want a system. I have my data layer. I have my BI layer. I really want my prediction layer, which really takes that problem seriously. Gives me an environment where I can run some experiments, and add features, gives me an environment where I can monitor performance over time, gives me an environment where I can, share features about my stores, my products, across different use cases, gives me a system where I can monitor, the drift between training and inference so I can get alerted on things, alerts me when things fail, or things aren't updated. And that's kind of a much bigger task than just, what is, sort of the BigQuery ML. So we are sort of a fan of SQL as the language to manipulate data. We're less of a fan of SQL. Like, we don't think that's the end, right? We think that that's just the beginning. We're using SQL as the data language, right? How do you manipulate and organize data? We're not using SQL as the ML language, or particularly like the workflow ML and experience that we think you need for operational AI. I hope that kind of makes that clear.
Yeah, definitely. And in terms of the sort of ways that you've seen the Continual product used and the just overall concept of declarative machine learning and being able to automate a lot of the operational aspects, what are some of the most interesting or innovative or unexpected ways that you've seen it used?
We were just chatting about this in our team meeting yesterday, actually. The most surprising, in some ways also encouraging aspect is honestly, it's not really one use case. It's really the breadth of the use cases and the breadth of the types of companies, and honestly, the geographic reach of the type of companies that we interact with. So just to give you like real examples, so it's like a makeup company, like a massive, like the L'Oreal of South America. That's not somebody you think of ML, right? They actually are a huge business, right? And they've got all sorts of actually ML use cases around their customers, their sales, their stores, their sellers, and all of this sort of stuff. In the morning, we'll talk to a company like that. Then, a couple hours later, we'll talk to like a genomics company that's doing like, genomic transcription, and they have, data quality for predictions that they need to, flag certain tests to be run again because they don't have 100% reliability and they need to have some intelligence around that. Then, the next day we talk to a freight forwarder or like a logistics, major logistics, company that's got trucks running everywhere, and what are the arrival times and how much demand is there going to be and how many drivers do they need, during different peak seasons and peak periods and in what geographies and all of those things. Then we talk to like a major, car company, like one of your top 10 car companies, and they're looking at, all the things related to, car inventory and sales, service revenue, and all these kind of use cases around selling and maintaining and servicing cars. In the financial space, you'll talk to like a pay now, pay later platform who's like, trying to do, scorecard, kind of more traditional financial scorecard stuff that's going on. You'll talk to a SaaS product company that's like building kind of like products for educational purposes, that's trying to do personalization, and so that people can have a more kind of personalized experience both within the product themselves and, mails that they get, in their email box saying, hey, you might be interested in these courses and things like that. Of course, there's like abuse and fraud prevention. So across a lot of different industries, there can be financial transaction fraud or, in application or platform, bad actors, fraudulent accounts or, fraudulent reviews or, just kind of like abusive language, in the kind of the gaming sector. We're a small startup, but actually those are all real conversations that I've had over like the last month. And that was just like the industries. The other aspect of that is like, it's in Europe, it's in South America, it's in, Australia, it's in the US, it's from startups to megacorps. And we're barely long. We launched 2 months ago, and not even with a press announcement. We're gearing up for some things, additional things. That's kind of the most surprising is just like sheer breadth. A lot of times investors, or just people would say, hey, focus on one industry, focus on one use case. And, it's very tempting because I do think it makes it much clearer to kind of describe your value proposition when you have these vertical focuses. But then I think, who am I talking to? I'm talking to all these different people, all of these different use cases. And it's just remarkable how broad data is impacting the world. ML is part of that, or these companies, any company with data now is starting to think about these predictive use cases.
In your own experience of building up the Continual product and creating the business around it and talking to customers, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
So the most challenging bit is probably hype versus reality. That applies both, to the customer, so their expectations versus their own reality, so having nothing to do with us as a company. Then I think equally, from our side, obviously there's tremendous excitement around AI and ML. It's hard to for customers to sort of see through hype versus reality, right? So I'm in this conversation, been talking a lot about declarative AI and what I think that is and trying to explain what that is. And it is a new concept, right? Or somewhat new. It has analogies to other things that hopefully are familiar. Kind of like see it to believe it, right? And so there's vendor fatigue, or there can be vendor fatigue around AI and ML. A big challenge is keeping kind of balancing this act between I do think that AI and ML is probably one of the most transformational technologies over the next decade. Certainly one of the things that is most exciting. It's why I'm working in this space. But you have to balance that with the reality. How do you actually deliver something of value? And then this gets down to personas as well. You have the ML engineers, which do you actually need to be? Can you actually automate all this stuff, or can you not? And so there's very valid critiques there. And so just navigating all that, and trying to build something that delivers value, stay excited about the future. I think that's been probably the most challenging. It's more of a sociological comment, I would say.
And so for people who are excited about the opportunity for being able to apply machine learning and AI to their business data, what are some of the cases where Continual is the wrong choice and they're better suited by building out the stack themselves or using an AutoML platform to understand what the capabilities are?
That's a great question. I think I read a blog post once, which was, a list of all the startups. And I think they said, what are you not? Right. So that was and every startup could pitch basically, what are they not? And it's actually very illuminating. So in terms of, use cases where we're not, currently at least, a good solution, we're not focused on sort of low latency real-time use cases. So if you're doing real-time fraud decisions for, credit card transactions, we're currently, not the right solution for that. If you're doing kind of real-time personalization, search re-ranking use cases, we're not currently, at least, the best solution for that. If you're doing, on-device or edge-based inference, right, you're training like image models that are going to deploy onto your phones to do text recognition on your phone or something like that for license validation or whatever for these that you see when you sign up for a scooter and they validate your license. We're not a platform for that. There's really exciting use cases, transformational use cases around factory automation, autonomous driving, genomics and protein, the protein folding use cases. We're not the use cases for that. So those are all great use cases for ML, very exciting use cases. And some of those I think we will be able to handle. I think declarative approaches to AI will solve them. I think real time, for instance, there's really nothing preventing us to extend into the real-time use cases. We actually had capability around real-time use cases. We just when we get there, we want to do it right. And now we just think there's a tremendous opportunity around these more continual in-database maintenance use cases. They're just, if you have many use cases really don't want an API. You want to say what customers are most likely to churn, not is this customer going to churn from an API call? So those use cases really belong in the data warehouse. So our sweet spot, is you have data in your data warehouse. You want to have predictions in your data warehouse. You want those predictions continually maintained. That's bread and butter for us. And the rest, some are on the horizon. Some other ones autonomous driving and robotics, not the platform. A different platform is better for that.
And you've touched on some potential plans that you have for the business, but what are some of the things that you have planned for the near to medium term of what you're building at Continual?
So the most immediate thing that we're actually working on right now, and we're very, very excited about, is really more around the development to production lifecycle and workflow for end users. And so this is, it maybe seems esoteric, but I actually think it is, just completely critical for developer tools and developer experience. You sort of need a principled way to think about, when you're doing development, when you're doing staging, how to keep that isolated, how to see the impacts of the changes that you're going to make before you actually deploy them into production. And then how do you get them into production? How do you actually make them sort of deployed? You can't just be a deployment platform without also thinking about the workflow from exploration to production. And so we're introducing like isolated environments, very similar to the way like DBT works, which kind of gives you this like early ability to like keep everything isolated, compare between your different environments, see the impacts of your changes, all while maintaining, a declarative workflow. So very, very high velocity, high productivity workflow, but still giving you that like core control that you need that gives you the confidence to be like, I'm not going to step on somebody else's toes. And I'm not going to step on production. So that's like something that we're just like, it's like a little bit more in the weeds, but it's like one of these actually like foundational bits of semantics and like workflow that so many platforms fail to address, right? They build these like really slick UIs, but they actually fail to like have that kind of core developer experience, core workflow that actually can support production. And because production and operationalization is like everything in Continual is in the end trying to get to production, that's super critical. So we're really excited by that. The next thing, which isn't like a technical element, is we are currently in private, early access, and you can, sign up, and we'll absolutely let you on the platform if you create a great use case. So definitely, sign up, and we'll get back to you like in a day. But we are, gearing up for, a public beta, much more broader availability, talking much more about, what we're doing, much more, open documentation and, tours of the product and a lot more. If you go to continual.ai right now, you'll see a lot about the product, but you won't see everything about it. And so we're gearing up for that in, in the next, 2 months or so, which is tremendously exciting after having spent, a year and a half, 2 years in development on this product and being very excited by how it's coming together. There are other things that we're working on more related to like the ML aspects. I hinted at some of those with my previous comments. Wait to announce those until they're ready. But I do believe that sort of generally, it's amazing how far you can push declarative approaches to AI into broader domains, multimodal domains, images, text, real time. Really nothing stopping us from going after that. But right now, we really want to make sure we absolutely nail the data warehouse-centric use cases with traditional kind of tabular and temporal data, the workflow around that's robust, that people really buy into, connectivity to your existing tools like DBT, where we really want to have a tight integration. And so kind of we're focused on that, kind of gearing up towards a broader availability, announcing some of our funding news, which we haven't announced yet, and steps like that.
Are there any other aspects of the work that you're doing at Continual or the space of declarative AI that we didn't discuss yet that you'd like to cover before we close out the show?
No, I think that's it. This has been great. I would definitely encourage people to check out what we're doing at Continual. I think, if you're just interested in this idea of declarative AI in general, I think, other areas to go, if you're just interested in sort of the declarative aspects of the AI part, maybe less about the operational aspects, are looking at tools like Overton. And there's some research papers that have been published on that from Apple, which is Apple's, they talk about how they are using declarative approaches of AI to, radically accelerate development of natural language processing models that power Siri. Just really shows, I think, the potential of it. The same sort of things around, Ludwig is a project out of Uber that is, quite exciting. The Snorkel project out of Stanford is another example that there's sort of these declarative aspects. And so I think there's just an exciting trend. I think we're going to see over the next couple of years, declarative AI enter the mainstream. And if we couple that with, making it operational, I think it has the power, dramatically impact the way we do production machine learning. Very excited by that.
Yeah, definitely excited to see some of the capabilities that will unlock, because there has been a lot of sort of hype about the potential for AI, but not a lot of realization of it because of the complexities that you mentioned. So for anybody who wants to get in touch with you and follow along with the work that you're doing to help drive that forward, I'll have you add your preferred contact information to the show notes. And as a final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
What an interesting question. God, there's so much. I love the data ecosystem. So staying away from the AI and ML space, which is obviously what I'm thinking about most. I do think there is still a tremendous opportunity around real-time data infrastructure. I do not think that real-time data infrastructure, from the actual streaming and storage of data, including things like replay. There's lots of frictions that I see in this space, from performance to scale to cost to the ability to store that massive volumes of data. And then, probably more importantly, the workflow around processing that data. So thinking about how do we actually operate on real-time streaming data, whether that's SQL and streaming approaches to SQL. Maybe you see tools like Materialize or Flink SQL, where kind of giving hints, Spark Streaming, obviously. I know Snowflake is putting a huge effort into their streaming SQL story that, in terms of they have building a big team there. And to also just programmatic access, right? Real-time data integration, is increasingly how companies are going to think about kind of stitching together data. I don't think like Kafka is like the answer, right? So it's not like you have Kafka and now the game's done. I think that there's, a tremendous opportunity to kind of think about, just rethink the whole streaming landscape, particularly hopefully with a developer-centric mindset, really thinking about how do we, make the developer experience amazing. Development to production, isolation, replayability, incrementality, all of these things that actually are really critical, delightful developer experience. I don't think that's kind of come to the data warehouse. I think tools like dbt, I think it's coming to ML and AI. I don't think it's really come to streaming. And so I'm looking forward to the startups and everybody else who's going to try to solve that in open source or, in the startup or maybe at one of the major clouds. So definitely excited about that.
Yeah, definitely interesting to see how the overall streaming ecosystem has been building up over the past 5 or 6 years and some of the potential that still exists that has not been realized yet. So I agree that there's a lot of interesting activity there, and I look forward to seeing how it plays out. So thank you again for taking all the time today to join me and share the work that you're doing at Continual. It's definitely a very interesting platform and has a lot of promise for helping businesses be able to gain the advantages of machine learning and AI to sort of improve their overall efficiencies and capabilities without necessarily having to invest months or years in building up the foundational infrastructure. So definitely excited to see where you take the business and appreciate all the time and effort you're putting into that. And I hope you enjoy the rest of your day.
Thank you so much. It was a real pleasure being on.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.